Okay, now let's solve one example and let's obtain the weak form for a given strong form. We are given a problem, so d over dx, a multiplied by e du dx, so just correct it, it's wrongly written like this, plus 10 ax is equal to 0. This is the differential equation that represents the problem within the domain, which is defined between 0 and 2 for x. So at x equal to 0, the displacement or the u is defined. It is defined as 10 to the power minus 4. And sigma is, so for this case, it is, we can say that it's stress. So it's defined, it is E du dx at x is equal to 2, and it is defined as 10. So let's solve the problem. In fact, what we do is we just take the differential equation first, this one, and we multiply it with the weight. So here the parenthesis is not here. It is wrongly written. It has to be here. Okay, so the brackets, square brackets begins from here. So it is d over dx multiplied by ie du dx plus 10ax. Okay, so this is our differential equation for any value of wx. Wx is the weight function. And we have now know that the traction boundary condition is defined. So it is WA, since it is E du dx has to be equal to 10. It's not a problem if I multiply it with the A area, and I can multiply it with the weight for weight is equal to 2. So this is known. In fact, in this case, when weight at x equal to 0 has to be 0. Okay, so let's continue further. Now, first thing that we have to do is to apply integration by parts to the first term. So this expression, when we apply integration by parts, we will obtain this expression. It is WAE du dx from x is equal to 2 to x is equal to 0 minus dw dx multiplied by area Young modulus du dx. This is okay. And now I will substitute this expression into my original equation, this one. Then I will arrive at this equation. So remember that W0, W at x equal to 0 is 0. So as a result, this is minus, and so I will arrive at this expression. It is minus from 0 to 2 AE du dx. That's also okay. From 0 to 2, 10 WAX dx. This is the body force or distributed forces, plus WAE du dx at x is equal to 2. Since W0, W at x is equal to 0 is 0. Okay, and this expression is equal to 0. Now, I know that E du dx is equal to 10, this term. from the boundary conditions, this term is equal to 10. Now I substitute it here, then this will result in such an expression. So here I also, in order to avoid the negative sign, I multiply the whole expression with the negative sign, -1. Then it will not change anything. So I arrive at this expression. So it is AE dw dx, du dx dx, and integration of this expression from 0 to 2 minus 0 to 2 10w ax dx minus 10wa at x is equal to 2, and this has to be equal to 0 for any function wx with w0 is equal to 0.